Hi everyone, my name is Karthik, and today we're going to talk about Unix. Unix is one operating system that has changed the lives of every individual on this planet, and yet we do not know it. Today we are going to see how the Unix application or Unix OS went on to become one of the most important software development to shape the humanity. They showed us the way how to precisely cut and carve a monolithic giant to a modular system that we still even today rely on. So let's get deeper and understand how this all came together. All right, let's set the stage. Imagine yourself in mid 1960s. The computer landscape was a wild frontier. Mainframes were the kings, and the idea of time sharing, letting multiple users interact with a single powerful machine was the holy grail. Bell Labs, MIT, General Electric embarked on a grand, ambitious project called Multics. It was designed to be ultimate operating system, a robust, a secure, and a highly complex beast. As you can see in this picture, it was groundbreaking idea, but it was immensely complex and unwieldy, a monolithic beast. This was a very ambitious project, but it was very complicated and it had its own caveats. Basically, our users would access this machine on a time shared slots. They would punch in their calculations and this would spit out the output. This was very complex and very hard to use. So this grew frustration among the users at Bell Labs. So the problems with Multics was massive and multitudinous, difficult to manage, and it was very hard to evolve. It was big, it was unwieldy, it was in many ways a testimony to challenge the building everything in one monolithic system. This made the engineers at Bell Labs more frustrated. Even Ken Thompson was very frustrated because of it, and he started tinkering on his own side project. So basically, Ken Thompson, a brilliant mind at Bell Labs, he let he was most part of Unix project, and he was working with the team members. He grew frustrated with its sheer scale and complexity, and he yearned for something simpler, something more elegant. He even had a little uh, PDP-7 machine, I think, a microcomputer which was sitting in his corner, and he was using it as a personal playground. He started tinkering with that, trying to recreate some of the most horrific experiences that he had using Multex. But he wanted to make sure that the application what he wanted to design is more smaller, like not building everything in a simple complex program. Rather, he wanted to subdivide the program into multiple smaller manageable chunks so that he started writing his own. He wrote a file system, a text editor called ED, and an assembler, a very small one. And he was building his own world, one piece at a time. Then soon, Dennis Ritchie, the author of C, discovered about this and he started joining him. And here is where the magic really happened. They weren't just building a system, they were forging a philosophy. They were they were very tired of the kitchen sink approach. They believed in something radical for its time. Small, sharp tool. Each program should be designed to do its own thing, and it had to be designed to do its own thing very well. That is what that is where they were thinking, and that is where they were focusing on. The Unix philosophy for small, sharp tools. These tools were thought of small parts like cogs on a wheel, which in turn turn on the wheel and making a complex machinery. And these tools were able to work together to be changed and piped creating a complex workflow for simple, composable parts. This, my friend, was the birth of Unix philosophy. They initially called us Unix, playfully with jab at Multics, standing for Uniplexed Information and Computing Service. It was a single task system at first, but the core idea was there. Now, here is the true influence point of the engineers. By 1973, the creation now known as Unix was gaining traction within the Bell Labs, but it was written in assembly language, which tightly made that to work on a single machine, especially PD11. This was the most significant constraint. If they wanted to spread it, they had to make it more portable. So basically, the core principles were making a small, sharp tool. Each program does one thing and it does one thing only well. And the problem was that it was built for a single use, single machine. And that is when Dennis Ritchie started thinking and he started working on a program that we all know today as C, which is uh, completely independent of the assembly code. So basically, what he did was, so Dennis Ritchie, with his genius, refined development of C programming. This wasn't just another program; it was a revolution. C offered over hardware, full control over hardware, while giving a layer of abstraction for the users who are doing it, who are writing it. Actually, it allowed them to rewrite the entire C kernel. Uh, so basically, what they did is they took this PDP, they wrote they PDP 11, as a matter of fact, they wrote the entire kernel in C language, rewriting an entire operating system kernel in a higher level language. This was a revelation at this point. Just imagine you are able to decouple things from a machine and you can take this code and run the same code on a different machine. It decoupled Unix from a specific hardware, making it incredibly portable. This single act unlocked its true potential, allowing it to adapt on a vast array of machines, from microcomputers to mainframes and eventually to desktops and servers that we all know today. This is when the Unix left home. So as you can see, the PDP machine over here. So basically, the entire program was built on that. So everything was hard coded to the microcontrollers that were there inside it, and also to the hardware. So as soon as they released it, everyone went mad. Uh, the the Unix operating system spread from Bell Labs to universities, research institutions, and commercial entities as well. Then the Unix war ultimately started. Everyone wanted their hand on Unix. Each adoption developed their own optimization, resulting in a fragmentation which we know as BSD, System V, Solaris, HP Unix, and many more. Similar but often more incompatible systems came into the picture again. So basically, what happened is everyone wanted their own version of or flavor of Unix, and this created the system dependencies. And it was hard. It was becoming hard again, so that there was no uh, a borderline or a borderline code, so that everyone can follow the same structure. Hierarchical file system, command line interfaces, processes, pipes became computing standards. And then the children of Unix emerged. In 1990, a Finnish student named Linus, inspired by Minix, started building his own kernel. and he called her as Linus, just taking his name there. It embarrassed on the open source model, fostering a global community of developers. Linux is in many ways a spiritual successor of Unix, embodying its principle of modularity, freedom, and power. So that is how the Linux was born. So Apple that we all use today is nothing but underneath a Unix system. The interface, the terminal that you see, the Darwin, so that is where everything runs on. It's a direct lineage of the original Unix system. Basically, it uses BSD underneath, and everything, the file system, the way it manages the memory, everything is from the Unix. Unix principle underpin a vast majority of modern systems, servers, workstations, and mobile devices. So that is how Unix is very important to us. So why is this lesson we are all having today? Because this Unix taught us a very important things so that we still use even today. Modularity and composability, the small scrap tools. Philosophy is the bedrock of microservices, usable libraries, and component-based architecture. Portability, the lessons learned from C, rewrite the information of our choices, but on a cross-platform development as well. Containerization and cloud-native applications were all because of this power of command line. Even the sophisticated IDEs, the ability to drop into a terminal and write a powerful Unix command line programs remains an indispensable skill for debugging, automation, and system administration. Kernel user space separation. Understanding its fundamental boundaries enables by the Unix is a crucial for operating performance, ensuring security and troubleshooting system level issues. Unix wasn't just an operating system, it was paradigm shift. It taught us how to build a complex system from simple, elegant parts. It gave us the tools and the philosophy to tame the wild frontier of computers. And even after 15 years in the game, the echoes of that 1969 PD7 still resonates in the line of code we write in every system that we deploy and every problem that we solve through code. Thank you very much. Bye.